Okay, so now let's discuss about the reaction of alkenes is hydrogen halide. So second reaction, proton chlorination, and this is the second type of reaction, reaction of alkene with HX or hydrogen halide. HX means hydrogen halides. So hydrogen halides means now you know what are the hydrogen halides. So it's HF, HCl, HBr or HR. So these are the hydrogen halide. So what's happened after addition of hydrogen halide into C double bond C? The reaction is C double bond C. So final product is after addition of any type of HX. So this is the main product. So hydrogen will join to here and X or halogen will join to here. So due to this reaction also, this is hybridization of this one sp2. After that one, the hybridization change into sp3. So this is the main reaction that happen in this reaction with alkene and hydrogen halides. Okay, so when consider about this one, so for example CH and double bond CH2. Now think about we are going to add HBr. So here when you add HX or HBr, you have to consider about any type of polar material or polar condition. In polar, they should have any type of polarization in this medium. Okay, HBr in polar media. Polar media means water or something. So after addition of HBr, what's happened is here H2 and one hydrogen will join to here, and here Br join to here, and CH2. This is the result. Another one here CH3 C double bond C, and here one hydrogen, and here one hydrogen, and CH3. Now think about you are going to add HI, and then result is CH3 CH and H double bond Br, sorry, not double bond, should be single bond, and here CH3 and H. So this is the product. So HBr just addition into these 2 points. So later we will discuss about what about the mechanism. Now think about this one, CH3 CH double bond CH2, and now think about we are going to add HBr, and here I think there's a problem. Now here you have to think about what is the point we have to add hydrogen, or here or here, and the previous one there is no problem, and equal number of hydrogen containing 2 carbon, no problem, hydrogen addition to either this one or this one, and here also no problem, the point of the addition hydrogen. But here 2 hydrogen in this carbon, and here only 1 hydrogen. Then you have to think about what is the point we have to add hydrogen, here or here. Okay, so you can't write the result for this one now. So there's a law, you have to follow this law to addition of HBr into carbon-carbon double bond or this alkene type of compound. Okay, that law now in this slide, so you can see this, see that law. That law we call as Markovnikov law. Markovnikov law. Now you can see Markovnikov law, and now you can see the definition of this Markovnikov law. Just read it. Okay, actually after reading this definition of this law, you can't understand very clearly, but I will say you examples. Now think about HBr, and here carbon-carbon double bond exists here, and here 1 hydrogen exists, and here now think about CH3, here hydrogen and hydrogen. Now in this compound, and this carbon contain only one hydrogen, this one only two hydrogen. Now I'll show you examples. Now think about, you are going to add HBr. So hydrogen just normally join to the side which has the greatest number of hydrogen, and then bromine join to less number of hydrogen which connect to this one. So this is the normal theory that explained using Markovnikov law. Okay, so this is a very simple example. I can explain you like this. Now think about, you are coming to the class, then what's happened to you like to sit the side which have lot of number of friends. ඒ කියන්නේ ඔයාලගේ යාළුවෝ ගොඩක් ඉන්න තැන තමයි ඔයාලා යන්න කියන්නේ. හයිඩ්‍රජන් කැමති වෙන්නේ. So hydrogen is more favorable which has highest number of hydrogen. ඒ කියන්නේ ඔයාලගේ යාළුවෝ ගොඩක් ඉන්න තැනින් තමයි ඉඳගන්නේ. අපි කැමති තැනකින් ඉඳගන්න නැහැ, යාළුවෝ වැඩිපුර ඉන්න තැනින් ඉඳ ගන්නවා. එතන then Br join to this point. So simply you can understand about geo movement, and here also same movement. The hydrogen join with highest number of molecules. That is the simple explanation for Markovnikov law. Okay, now you have to follow this Markovnikov law when we are addition to HBr into any type of carbon-carbon double bond. Now let's consider about some few examples related to this one, then you can get some more idea about this one. Now think about this one, and first example, okay, the one examples. Now think about this one, CH3 CH double bond CH2. Now you are going to add HBr under polar condition, then final result, hydrogen will join to this point and bromine will join, sorry, hydrogen will join to this point, and then bromine will join to this point, and this Br hydrogen going to here and Br going to here. Then final result, CH3 CH. Then this hydrogen will join to this point, and this Br join to this point, and then final result will be Br to here and this hydrogen to here, CH3. So this is the final result. And the next example, let's consider this one, CH3 twice C double bond CH2, then HBr under polar compound polarity, and then hydrogen will join to here and Br will join to here, and then final results, CH3 twice C Br and CH3. So in the conversion, when you do the conversion, you have to follow up for this type of examples. Okay, so third one, CH3 twice C double bond CH CH3, then final answer, CH3 twice C Br here and here, CH2 like this one, hydrogen and hydrogen, and then CH3 into this side, then this is the final one, and CH3 here, and these are the result related to this one. Okay, then this is the normally result that can obtain during the addition of HBr into any type of alkene. Okay, then you have to understand what is the mechanism related to this. Okay, so first we'll study the mechanism related to addition of addition of HBr into ethene. Okay, let's consider about the mechanism of HBr addition on ethene. Now we can discuss about the mechanism of HBr addition of ethene. Ethene means C double bond C, here H2 hydrogen and HBr. When consider about HBr and here hydrogen and here Br, just polarized as delta minus and delta plus, here negatively charged, same as previous addition of chlorination reactions, same mechanism here, just electron into this side and then this bond will break into other side and then final result form H2C plus and CH3 plus Br minus. So this is the first step. At the second step, what's happened? Just remain Br minus will attack on CH2 plus CH3 on this plus 1 and then final result will be CH2 Br and CH3. So this is the final result during the mechanism. This is the what's happened to addition of HBr into ethene. Ethene means this one. So this is very simple step, first and second step. So you have to make your note based on this one. So then we have to discuss about mechanism of HBr addition on propene. Propene, I just explained about this one. Propene means CH3 H double bond CH2 and here this CH3 is electron donating group, therefore this electron cloud is just draw into this side and as a result of that this one delta minus and this carbon delta plus. So HBr here delta plus and delta minus, delta minus of bromine due to the electronegativity and polarizers, therefore plus there is attraction on this carbon by this electron cloud and here then break into this side and then final result CH3 CH plus and CH3 plus Br minus. So at the second step what's happened, this Br minus attack on this one and final result will be CH3 CH Br and here CH3. So this is the result and two step mechanism. This is first step and second step and here also first step and here also first step and second step. So you have to clearly understand what about the mechanism related to this addition of HBr on ethene and propene. So here and then let's consider about what are the other reactions. So when you consider about HBr addition, I just clearly explain you when there is a I just explained about HBr addition now. Now I am going to discuss about some special theory. We call it anti-Markovnikov law. Normally we know anti-log. Anti-log means the vice versa of the log. So anti-Markovnikov law means now in this slide you can see anti-Markovnikov law. This is some definition, but I will explain it using some simple theory. Now think about you have given this type of CH3 CH and double bond CH2. Previously we discussed about using the Markovnikov law in the presence of polarized media. This is a hydrogen going to the side which has highest number of hydrogen and bromine going to which has less number of hydrogen. So that is a simple theory. So anti-Markovnikov law says if there exists any type of peroxide media, peroxide means H2O2 or normally we call R2O2 also. This is called organic peroxide and this is hydrogen peroxide. In the presence of this type of peroxide, so hydrogen should go to the side which has the less number of carbon. That is the theory. So now think about as an example. Previously I explained, when addition of HBr in the polarized media, if you come to the class, you are going to the near your friend which has a highest number of friends. That is the normal theory. But now think about when addition of HBr in the presence of this type of organic peroxide media. So now think about, this is organic peroxide media as me. Then now you come to the class, but you can't go to the place what you want. And then in the class I said you have to sit in the last row, or you have to come to the front row. Then that is depend on this media. So that is depend on my order. So likewise, if there exists a peroxide media, then hydrogen should go to the less number of side. That is the anti-Markovnikov law. So CH3 and CH and H2 here, and here you have to add Br and CH2. So anti-Markovnikov law means hydrogen should go to the less number of molecular side. So therefore hydrogen should comes to here and bromine should comes to here. So this is the normal definition for anti-Markovnikov law. So in some explanation and some conversion, you have to use this theory. Okay, so that is the simple theory you have to use. Now think about this one, CH3 CH double bond CH2. I'm going to add HBr in H2O2 media. Then result is CH3 CH2 CH2 Br, because Br going to here and hydrogen going to here. And here another example, CH3 CH double bond C CH3 twice. Now I am going to add HF in the medium of H2O2. Then hydrogen will go into this point, less number of hydrogen, no hydrogen, and here chlorine will go into this side. Okay, then CH3CH and fluorine into this side, and here CH and CH3 twice. So this is the final result. So you have to study about this one, and what says the anti-Markovnikov law, and that's mean in the presence of this type of organic co-peroxide media. That mean same as me at the class. So hydrogen going to the side, that what say this compound says, and then you have to go to that place. That's the simple one. So these are some explanation. So I will show you some examples about some conversion. Okay, now think about some simple examples. Oh, okay, so this is simple one. Okay, now CH3 CH2 CH2Br, and you want to convert this into CH3C Br and H and CH2. How to convert this into this one? Then now think about first you have to add alcoholic KOH and heat. Then what's happened? CH3 and here HBr, hydrogen and Br will remove, CH double bond CH2. This is the form compound. Then you have to add HBr under R2O2 media or peroxide media, R2O2 peroxide media. Then hydrogen going to then you have to add HBr in the presence of polarized compound or polar compound, polarity. Then hydrogen going to here and Br going to here. Now think about this one, another example, CH3 CH Br CH2. You have to convert this into CH3 CH2 CH2 Br. Okay, now I am going to add alcoholic KOH, just it, and then HBr will remove. Then final answer CH3 and CH double bond CH2. Then you have to add Br, and here you have to add HBr under R2O2 mean, then hydrogen will go into this side and bromine will go into here, then final answer. So these are some simple explanation for some conversions. Okay, now then let's discuss about the third type of reaction of alkenes. Third one, reaction of alkene with dill H2SO. Reaction of alkenes with dill H2SO4. Dill H2SO4 means, so normally we called this reaction addition of H2O molecule. So this is the normal theory we can use for this one. So alkenes are normally immiscible with water. So if you want to add any type of water molecule to this one, we have to follow up some procedure. So first we have to add this type of nothing conch sulfate. Now think about this one, CH2 double bond CH2. If we add conch H2SO4, as I explained in inorganic chemistry, conch H2SO4 just dissociates as H plus and HSO4 minus. So after addition of this one, what's happened is CH H and here C, here HSO4 minus and H2 and plus H plus. At the second step, what's happened, then after addition of water, we have to add water to this one. Then what's happened is H plus from this one will connect with this bisulfate, and then one hydrogen with OH will join to here, H plus and OH minus. Water means then hydrogen will H plus will join with this one as a sulfuric, and here H, and then H plus will react with this one to remove as H2SO4. Then OH will join to this point, see, OH, H and H. So now, so as these are two step, conch sulfuric first and then secondly water. So normally in organic chemistry we use this as a dill H2SO4 to add water molecules into any type of alkene. So that is the theory we have to use here. Okay, now think about very simple examples. Here CH3 CH double bond CH2. If you want to add water molecules here, just use dill H2SO4, and then final answer will be hydrogen will same as Markovnikov law. Here also hydrogen will join to the side which has high number of molecules, high number of hydrogen. Then hydrogen will join to here and OH will come to here. Then CH3 CH OH and CH3. So this is very simple. Now think about this one, another one, CH3 CH3 double bond CH2. After addition of dill H2SO4, CH3 CH3 and CH2, then hydrogen will join to here as one hydrogen and here OH. So this is very simple. So in the mechanism I just explained, the purpose of H2SO4, conch H2SO4 act as a catalyst. It does not join to the reaction. So this is the purpose of H2SO4 in this reaction. And so in this reaction, this part, conch H2O4 attacks catalyst. So it is the point. So you have to understand this one. So this is about the third reaction of the alkene. So now you know, if you want to remove water molecules, you have to add conch sulfuric. If you want to add water molecules, you have to use dill H2SO4. Just keep in mind because it is very a special part. And then we move on to the next part of the reaction, and that is about the oxidation of alkene. Okay, let's consider about what about the reaction type, fourth reaction. Okay, fourth one, oxidation of alkene. Okay, oxidation means here you have to use alkaline MnO4 minus. Now after addition of MnO4 minus to here, addition of MnO4 minus basic medium to here, the what's happen is, and two OH groups will join with this one, and here you can see H2C, and one OH will bond to here, another OH will bond to this point, and here CH2. So this is what happened during this reaction, but the important thing is the what's happened is MnO4 minus here basic medium and convert into MnO2, and this is solid, brownish black solid. So this is the very important thing. Just MnO4 minus converted to MnO2, and OH will bond, two OH group will join with double bonded carbon, and here also this is brownish black precipitate. So this is very important reaction because this is identification reaction for carbon-carbon double bond or unsaturation. So previously we discuss about another reaction, identification for unsaturation. It is related to bromine liquid test, and this is another one. The reaction, the color change is MnO4 minus basic medium OH minus convert into MnO2. During this reaction, this color change from purple to this one brownish black precipitate. So this is the color change during this reaction, therefore you have to understand. And this is another identification test for alkene or unsaturation or carbon-carbon double bond. In this reaction also you have to write some examples. Now think about this one. First example, and CH3 CH double bond CH2 after addition of MnO4 minus OH, the result is CH3C, and here OH will join and this hydrogen will remain here, and see OH and H2. So this is the product. Two OH will join with this carbon. So after this reaction also, the hybridization of this carbon sp2, and then just here sp3 just change into sp2 to sp3. So these are the main reactions of alkene. So I think now you have idea about formation method and reaction methods of alkene and alkyne. So at the end of the every part you have to make some short note. So I will show you how to make a short note related to this formation of alkene and other type of compounds. Okay, so Okay, now think about alkane. Just try to hear alkane, and here alkane, and from this you have to write what are the formation method. I just explained about 4 formation method. Here what is the initial compound, and here write the formation methods from this side formation, and for this side write reactions. So this is enough short note for the alkane for your purpose, and go to the alkene also, and in this side formation method, 3 formation method. Into this side what are the reactions. Very shortly, just take all things into the one page as a summarization. Okay, so then we'll meet on the next video about the alkyne.